Hi, everyone. Let's do some Excel. All right. So let's go back to our 95% confidence interval for the population mean amount of ice cream per carton. Our example one from lesson 28. Okay. So here are the key sample statistics. This was predetermined. The sample size N is 19 cartons. The sample mean, X bar, was 17.2 fluid ounces. Of course, that's determined after we get our sample. You might even use Excel to figure that out. Get an Excel worksheet, right? And then you have 17, or what was it? Sorry, 19 cartons. 19 cartons. You figure out how much ice cream is in each carton. You have these 19 amounts of ice cream, and you can find the sample mean. The sample standard deviation we won't need because we're assuming we know sigma, the population standard deviation. We assume sigma is 2.35 fluid ounces. So on Excel, to find a 1 minus alpha confidence interval using Z critical values, so we're using a Z distribution. Again, we're assuming sigma is known, so we're using Z. So here's the form that we use in Excel to find E, the margin of error. Confidence.norm, that uses a standard normal distribution. Alpha, that's the complement of the confidence level. So if alpha is, so if the confidence level is 95%, all right, then 1 minus alpha is 0.95. That means that alpha itself is 0.05. So we want to use, in our example, alpha is 0.05. The population standard deviation sigma is assumed to be 2.35 fluid ounces. The sample size N equals 19 cartons. So that was all this sample data here. Well, this here is sample data. This is the population standard deviation. That's presumed known. All right. So let's type this in. And this will give the margin of error equals confidence. Can I spell? Confidence.norm 0.05. That's alpha. Sigma, the population standard dev, is 2.35. 19, the sample size. And we get, whether you round off or round up to be conservative, you get about 1.1 fluid ounces to 1 decimal place, like here for X bar. So 1.1 fluid ounces. And then you would get the lower limit and the upper limit for the interval by taking the sample mean, X bar, okay, and then subtracting the margin of error for the lower limit. For the upper limit, you would add the margin of error. All right, so for the lower limit, it's the sample mean 17.2 minus, or you could refer to a cell that had the sample mean, minus the entry in A8. Okay, and this rounds down to 16.1. Well, the thing is, if you're using the margin of error as 1.1, then yeah, 17.2 minus 1.1 is 16.1. All right. For something like this, you could round out, meaning you round down the lower limit, you round up the upper limit to be conservative. Don't freak out about that. All right, but yeah, 17.2 minus 1.1 is 16.1. For the upper limit, that's going to be 17.2 plus A8, the margin of error. Okay, and we get 18.3 fluid ounces. Again, 17.2 plus 1.1 is 18.3. Again, if you're playing it conservatively, then you would round out. I would say rounding out, which means you round down the lower limit and round up the upper limit to be conservative. Again, don't freak out about that. All right, so we get the interval from 16.1 fluid ounces to 18.3 fluid ounces. Remember, how is the 99% confidence interval different? It's going to be wider. The 99% confidence interval will be wider than the 95%. Let's check that over here. The margin of error is going to be bigger. Confidence.norm. Alpha is 0.01. If alpha is 0.99, sorry, if the confidence level is 0.99, then alpha is 0.01. Same standard dev, sigma, same n. And we get about 1.4. Remember, that was the margin of error we got for the 99% confidence interval. right here, 1.4 fluid ounces. All right. So this rounds off to 1.4, or you could round it up. To get the lower limit, you take the sample mean minus E. For the upper limit, is the sample mean plus E, the margin of error. And we get from 15.8 to 18.6, whether you round off or out, 15.8 to 18.6. 15.8 fluid ounces to 18.6 fluid ounces. So we verified that. All right. We'll deal with T distributions later. That's when we don't know sigma. We use S. That'll be later. Okay, so that's how you can use Excel. Granted, if you use something like StatCrunch, StatCrunch will just pop out the confidence interval, but it's good to know where these things come from. And it's good to know how good old Excel can deal with these things. Next time, we're going to deal with the T distributions and what happens in the more realistic case where we don't know sigma, we use S instead, the sample standard deviation. Next time.